Hello and welcome back. In this video, we want to take care about something in the real world. Yeah? Up to now, we just used this little LED on our Arduino, turned it off and turn it on. Now I want to turn off and on an LED in the real world. So outside the Arduino. First of all, what we've got here is failure in communicate. Some man you just can't reach. No, of course not. This just reminded me of a song. And for those who know, you have it now, a wonderful song in the top of your head. Yeah, you're welcome. So where were we? Yeah, what we've got here. We've got here some LEDs. What means LED? LED stands for light emitting diode. L, light, E, emitting, D, diode. What is a diode? A diode is some semiconductor. I'm sure most of you know that there are materials who can who do conduct, yeah, who where electricity can pass through, yeah, mainly metals, yeah. Then there are materials where electricity just can't pass, yeah. Isolators they are called, and then somewhere between there are materials where you can select how good electricity may pass. Yeah, those materials are called semiconductors, auf Deutsch Halbleiter, and those semiconductors do have different Eigenschaften. They have some properties. This is what I'm looking for. They have some properties. You can basically a semiconductor is an isolator which is dirty by some different type atoms, and then you can select the behavior of the semiconductor. And one of these semiconductor things is called diode, and a diode is sort of a valve for electricity. So on a diode, the electricity can pass from one side to the other side, but not reverse. That's basically the feature of a diode. It only can pass in forward direction. The same is true for these light emitting diodes, but when passing through the semiconductor material, which is up here on the top, somewhere inside this epoxy resin coat, yeah, the material emits light. Okay, so if the electricity is traveling from here over to here, yeah, then this thing is lighting. And based on the material which is inside there, a diode is emitting a certain wavelength. Yeah? So there is a different material in green, red, yellow, blue, white, LEDs, all different materials, but the principal function is the same. If electricity travels from the plus pole or the anode to the cathode, to the minus pole, then here this thing will emit a certain wavelength. So red, this one will emit red, this here will emit green, this here yellow, this here blue, and this here white. That the coating is also in this color does not really matter. Even if it's clear epoxy resin like here, this green one would still light up green. There are even diodes which are clear. However, if you grab into a box full of diodes and you don't know which color you are grabbing for, and everything looks the same, white or clear, then you don't know is it a green, a blue. So that's the reason why these coatings are also also with color. If electricity tries to travel through the other side, yeah, from the cathode to the anode, yeah, then this is not possible simply. Yeah. So I have to put on the anode side the plus pole, on the minus side the minus pole, and then electricity will travel over the semiconductor material and light will be emitted. How to distinguish between the plus and the minus pole? You see here several diodes. They are 5 mm diodes in diameter. There are also 3 mm. There are square ones. There are different forms, yeah. And you see there are even so small diodes like here. However, these bigger ones here you have in your starter kit. There is a long end and a short end. The long one is the plus. Yeah. You can maybe imagine or remember the plus is longer. Yeah. Plus is more. So this is, here you should add plus and here is minus. There's also one thing you should know about LEDs. If you just add here plus and minus, a lot of electricity will travel. So the current is very high. Yeah? Starting from let's say 0 volt, no electricity is floating. Then 1 volt, no electricity is floating. And at some point, suddenly, if the a certain voltage is we are above a certain voltage, a certain trigger voltage, then this semiconductor material here suddenly switches to conduction. Yeah. So then the charges can travel. So current is flowing. And if you increase the voltage higher, then a lot of more current is flowing, and then these diodes will be destroyed. So here on our Arduino we said we have a 5 volt output, so if we set it to high, yeah, we do have 5 volt on the output. So, and here we do need different voltages. The red one needs a little bit less, the green one needs also a little bit less, the blue one needs a little bit more, the blue one would need around 3 volts, this one 2 point whatever. You need to look up in the datasheet to know exactly. What to do with the other voltage? What to do to not destroy this LED? Please don't try it. It sounds more fun than it actually is. It will not smoke. It will nothing. It will not burst. It will not explode. It will not smoke. It's just gone. Yeah. So it does not make sense to destroy it. So what we need to add are things like this. These are resistors. A resistor is nothing more than adding additional friction to the current, yeah, to the charges which are traveling, to the traveling charges. This will add additional friction to these traveling charges. And if we select the correct size or the correct friction, the correct break size, let's say, for the charges, then we manage that 5 volt will not destroy. Some of the volts will drop here, and the correct amount of volts will drop here, so that only a certain amount of current is flowing. It will be around 15 to 20 milliamps, then we are fine. Yeah? If we add this before or after the diode, does not really matter. Okay? We just need to add this to not destroy the diode. it does not really matter if we are using a white one, a blue one, a yellow one, does not really matter. The correct size of these resistors is 220 ohm. It's called ohm. Nothing to do with yoga. 220 ohm. You can read it on this package here. Just pull some out, or these lines on the resistor itself, they also code somehow 220. So you can be sharp. No. So there are some lines which are coding this. But where to put it? I mean, these resistors and these diodes, they cannot be just somehow connected. They are not fitting perfectly together, and we don't want to solder here. Yeah. So then this thing here, this white thing, comes into action. This is a so-called breadboard. It's nothing more than a connecting board. So all those little holes we can put in a device. Yeah, I will now use this green one. I remember now, plus is on this side, so I will plug it in. You see, you can just push it in there. Of course not pull, you can push it in there. Yeah. How is this breadboard connected? Those holes, they are not isolated to each other. Yeah. Every line here is connected to each other. So 15, 16, 17, 18, 19, 20, all those lines are connected to each other. This is 1, 2, 3, 4, 5 holes. They are all connected to each other, but not to the neighbor. So the lines 19 and 20 are not connected to each other. So this is why I put in here my diode like this. Now this line is connected to the plus pole, and this line is connected to the minus pole, to the cathode. Okay. So I will move it a little bit far away. Pack. Yeah. This is plus, this is minus. Okay. How do I connect now to our Arduino? You also have in your starter kits such cables. These are jumper wires, they are called. They are in different colors, they are in different lengths. You should use the red color for plus, the blue color for minus. That saves a lot of trouble when searching. Yeah, put away all those other LEDs. Just use the green one. You can use whatever color you like. So I said here is plus and here is minus. So I use a jumper cable and another jumper cable, a blue one, a red one for plus. I will add to the plus, and a blue one for minus. I will add to the minus. Okay. These are just distribution bars here, so these are all connected. You can see it with this red line and the blue line. Two separate connector bars, yeah, where you can distribute plus and minus through all your breadboard here. Okay. Have I done a mistake? Of course I've done a mistake, because I really did what I first said you should not do. Add here, if I would add here plus 5 volt and here minus or 0 volt, this would immediately be destroyed because there is no resistor. How to put in the resistor? Just pull it out here plug it in here, bend the resistor so that it can fit, yeah, on your breadboard. Looks like this somehow, yeah. And then comes the tricky part, try to push it in. Yeah. It's not that easy as it looks. No, you will see on your first tries it's a wiggly and so on. So what we've got here, how we connect it, from plus we go to the resistor, through the resistor to the anode of the LED, through the LED to the cathode of the LED, and from there to the minus. Yeah. This cable here, yeah, I could also remove it and directly connect with the resistor from plus here to here, then have less cables. Also a good trick, yeah? Because the less cables you have on your breadboard, the more the better you will see what is happening. Okay, how do I test my network here? I said our Arduino has a power bar also. We can see here we have here 5 volts and we have a ground. So 5 volts are plus. I connect the 5 volt to plus, to the plus distribution bar. Cluck. I connect a ground pin, whatever, which one you like, to the minus distribution bar, and then it should work. Okay, at least this is what I would expect, that this is working. How do I test it? I simply plug in my Arduino and see if this is working. Okay, it's lit up, but not very bright. Yeah, why is that? Huh? Anyone an idea what the issue might be? The issue is this one. I didn't use 220 ohms, I did use much more. Yeah. You can see it on the rings. Yeah. If I pull it out and use the correct one, now this resistor added too much friction to the charges. Yeah. Now I add another one. That already looks different, right? So if the resistor value is too high, two less charges are traveling, and this will not light very bright. Yeah. Now it looks good. It's lighting very bright. If it's not working for you, please check if you maybe switch the direction. And now switch the direction of the LED, plug it in the other way, you see it's dark. Yeah? This is because an LED is a diode, and on a diode it's only working in one direction. You may be confused plus and minus. Check if the long connector is at the plus pole and the short one is at the minus pole. And you can use any color you like. So if you like it red, pull in the red one. If you like it blue, yeah, if you're feeling blue, don't bother, use the blue LED. You can see the Arduino is still blinking over there. Yeah? Why is this? Because in our last video we told him it should do so, and it still does. Yeah? It remembers. remembers. Okay, so now we know this LED here is connected good for us. Yeah. Now we want to have it turned on and off with the program. Yeah, we do not want that this LED is blinking here. We do not want to blink the LED on the board. We do want to blink this LED. Yeah. So the plus is now not coming from the plus. The plus should come from our Arduino. Okay. So I'm removing this here now from plus. I will plug it in to some random connector, plug it in here, and which pin do we prefer? I use pin number 3. Okay, so I plugged it in here to pin number 3. Yeah. I will now remove this one so that we can see it better. I plugged it in on pin number 3 here. Yeah. It will go from pin number 3 to the resistor, from the resistor to the LED, from the LED to the minus distribution, from the minus distribution to the bar. This one, the plus distribution, I don't need. I will pull it out again. Pull it out again. Yeah, and that's now our network. Now we want to try to alternate our program, yeah, in order that this external LED is blinking. That's the goal. By the way, in your script, in your description, you should have all the information, also how is LED built like. You see, this picture is from Wikipedia. You can also look up in Wikipedia. Yeah. This is the Arduino, that's the network plan. Well, and you also have the description of the breadboard, how they are connected, and you also have this test. Yeah, this test with the 220 from plus to minus, and so on. Okay, so this is our last program. This was our last program. Okay. I will add now another compile time constant, define LED pin, yeah, and we added it to pin number 3. Yeah. And now the only thing I have to do is replace all those LED built-in with LED pin. Yeah. I could also write, of course, here 3, 3, 3, yeah, would work as well. But like said, I think a proper way is that you use those constants, because if you want to change the pin number, you just have to change here, and this is working everywhere in your code. Okay, I will save it under a different name. Yeah. Blink external, and I will download it to our Arduino. Flashing. Nothing's working, right? Nothing's working. Why is that? Anybody an idea? Let's have a look. Let's have a look on our the issue. Yeah, you might also see these issues. We put it here in the third pin, yeah, but it's starting to number by 0, so it's 0, 1, 2, it's pin number 2. It's pin number 2, stupid. Okay? So, what we do is I simply change here the pin number. Now it's a good idea that I've used this constant because it's a minor issue. Now download and ooh, it's blinking. I'm happy. Okay? So, now we have told our Arduino, please turn on and off. Pin number 2 should be an output. That's what we have told. Yeah. And we told him, please turn off and on the output on pin number 2. And in the real world, something is happening. Okay. Here we see something is indeed happening. Good. Yeah. If you have managed it that far, you can program and digital output on your Arduino. So you can influence the world around you, because you know, if you turn on and off an LED, or turn off on and off a motor, or turn on and off a heating or whatever, is not that much difference. You will see we need some things between. We will do this afterwards. But basically it's just turning, from the Arduino point of view, it's just turning on and off an output. That's it. Okay. You also have this in your script. You also have this program there. Yeah. That's the training, which you just shown. And then there is your task. And your task should be, you should add a second LED. Yeah. And this second LED should always light if the other one does not. Yeah. So it should look like, if you add a second LED, it should look like ping, 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 ping. Blink left, right, left, right, left, right. Yeah, like the lights on a police car or something like this. Yeah. Left, right, left, right, left, right, left, right. And this is how it should look like. Yeah. 2 LEDs which are alternately lighting. Ding dong, ding dong, ding dong, ding dong. Good luck. This is your task. Try to fulfill it. Yeah. Remember the resistor. Yeah. Okay. Then that's it so far for this video. Thanks again for your attention. Next time we will read an input. Now we know how to write an output. Next time we will read an input. That's the next thing which will happen. So long. Thanks you for your attention. Yeah. Good luck.